Hello everyone, welcome back friends. Today we are going to see third and fourth central moments in data science. In our last lecture, that is the part 1 of this series, we have seen what are the central moments, what are the applications. In brief, we saw the applications of first raw moment, that is the mean E of x, that is nothing but the mean. Then we saw uh, the second central moment, that is nothing but the variance. What are the applications of variance? And also we saw how to apply it in the R software on actual data. So with that, we need to start for the third and fourth central moments. Now before I go ahead, I would like to request you to please kindly like, share and subscribe to my channel. Okay, let's move ahead. Now let me give you a simple example where third and fourth central moments are used in data science. Suppose that I give you an exercise, so you are my consultant and I ask you, so let me know how I should plan my YouTube ads. What should be the basis of that? What are the parameters on how I should um, uh, flash my YouTube ad content? So definitely what you will be doing is first you will be looking at the data of the visitors. So first is the data of the visitors. Secondly, you will see, okay, let us you will see what is the average number of people. You will see what is the average number of people who come every day. And thirdly, you will see the variance which we saw. So variance is nothing but the spread of data around the mean. So let me show you by uh, giving an example. So okay, so if this is the distribution, number of people and maybe time of the day. So this is how it is distributed, and this is the mean maybe. So this is the mean, and you can see this is the variance. But let me ask you one question. Is it really necessary that all the data in this world are all happens to fall on such type of a curve, which is a symmetric? You can see this curve is symmetric and dumbbell shaped. No, the answer is no, because it may be like this, or it may be like this, right? So what this means is your most of the public watches your YouTube video at the daytime and not in the night time. And this means that most of the public on your YouTube watches your video at the night time. So this will give you an idea how to place your ads. So that's how you are going to look at it. And another thing is there may be different shapes. If I take this as the standard, your curve may be like this, or your curve may be like this. It may be highly peaked, it may be low peaked, or it may resemble something called the normal distribution, which I am going to see, which I am going to discuss in my upcoming lectures. Okay, so we are going to today focus on these factors: how the curve is tilted and whether there is a peakedness in the curve. This is called skewness. This is a skewness of the curve. This is nothing but positively skewed, we say, and this is negatively skewed. Okay, so this is the base of what we are going to see, and let me go to my next slide, which is even more interesting. So keep on watching this video, because in the end I'm going to show you how to apply this concept in a programming way in the R software, which will make your work very easier. You don't have to calculate on data sheet or Excel sheets. Okay, coefficient of skewness. So you can see step 1. So step 1 is nothing but mu 3. Mu 3 is the third moment. And how do we calculate mu 3? So if we are calculating it by the means of Excel or on paper. So this is how we calculate to the power 3. So this is the definition of third central moment. This is my data point, and this is the average of that data point, and I'm taking it raised to power 3, and I have to sum it from 1 to n. So if you have like 10 data points, so you'll have to do this for 10 times x1 minus x bar to the power cube plus x2 minus x bar to the power cube divided by 10. That's how it works. And similarly, this is my second central moment, which is nothing but variance, which we have seen in our last, which we have seen in the last of our lecture. And you can actually watch that lecture. It will clear your doubts to a very good extent. I will be posting the link in the video itself and maybe in the comment also. Okay, so moving ahead, so this is nothing but step 1. Find beta 1, which is nothing but third central moment square upon cube of second central moment. Let me also write what it means so that you don't get confused. I equal to 1 to n x minus x bar upon square. So this is the definition of the, the algebraic definition, I will say. But you don't have to really do this because it is a time-taking exercise. What if there are 100 data points? So I will be sharing that code with you as well, how to calculate it quickly in R software. Now talking about step 2, so you have to find lambda 1, which is nothing but root of beta, that is beta 1, that is beta 1. So once you find out, you will have to compare and see the values. For example, if your lambda 1 is equal to 0, then it is a symmetric curve. So it is a symmetric curve. Now if your lambda 1 is greater than 0, then it is a positively skewed curve. So it is basically tilted to the left. That's what it means. So most of your data points are on the left hand side. That's what it means, and the tail extends to the right hand side. And similarly, if lambda 1 is less than 0, that means the curve is tilted to the right side. So your tail is towards the origin. So that's how you calculate and analyze a data given. So now this will give you an idea when, at what time of the day you should actually put your ads. Because if you put your ads, if for example, if your data is positively skewed and you plan for advertising on the night time, then there will be very less viewers. So that's how you need to strategize. Okay, so this was about coefficient of skewness. Hold on to the end of this lecture because as I said, we will be looking at the direct formulation or direct programming in the R language. Now let me talk about the peakedness or kurtosis. So coefficient of kurtosis. So similarly, mu 4 you have to calculate here. So mu 4 is given by 1 upon n. So similarly, xi minus x bar, which is the average, to the power 4, right? So that's what it means. So mu 4 is a fourth central moment, and and mu 2, which is the variance square, and the step 2 is to find out lambda 2 using beta 2. Now after you find beta 2 and lambda 2, you have to do a very simple thing, that is just see what kind of beta 2 and lambda 2 values you get. So if beta 2 is greater than 3 and of course lambda 2 is greater than 0, your curve is leptochaotic. This is called a leptochaotic curve. If beta 2 is equal to 3 and lambda 2 is equal to 0, then it is mesochaotic, which is also a form of normal distribution, which I will be discussing in my next lectures. And if beta 2 is less than 3 and lambda 2 is less than 0, then your curve is platychaotic. That's what that's the that's how you will know how your traffic is spread, if it is having a peak or if it is distributed over the end or over the period of the day, or how it is, or even if it is a normal distribution. So now you have all the necessary information which is required, and let us see how to do it in our software. Now in our software you have to first install the package which we have seen in the last lecture. So install.packages moments, this will install your package, and then call for that package library in bracket moments. Then sample base skewness coefficient, I am calling it sample base because we have a discrete value which we will be taking. We will be taking a sample out of which we have to calculate. So skewness, it's a simple command, skewness in bracket x, and kurtosis simple bracket x. But what is x? X is nothing but the set of data on which we want to find the values. So let me just take you to actual R software and let me demonstrate how we are going to do that and calculate in the R software. So we are on our R software interface where we will be demonstrating the actual usage of the skewness and kurtosis and how to infer the values. So let me first call the package which we have installed in the last lecture itself. You can watch the part 1 of this. Library moments. So I have called the library. Now let me first define a x variable. So just for the sake of example, I've taken this a random set which may be the marks obtained by students in a particular subject. Let we have called it as x equal to c, in bracket there are 10 values. Press enter. Now say I want to find the skewness. So skewness of x in bracket simple. So the answer is 0.6292. So this means that that our curve, the skewness, is near to symmetry, as we said that it is, if it is greater than 0, or is if it is equal to 0, we have a normal distribution curve, and if it is greater than 0 then it's positively skewed, and if it is less than 0 it is negatively skewed. Now similarly, let me find the kurtosis. So kurtosis x, so 2.513. So let me take you back to the slide where we saw the inferences. So we got 2.5 here. So you can see if it is less than 3 here, but it is very near to 3. So we can say that it's kind of near to mesochaotic, though by definition we will call it platychaotic. And as we saw that the beta one comes to, so the lambda one comes to around 0.6 we found. So it is near to a symmetric curve, but it is not less than 0, or so it is never definitely not negatively skewed, but definitely it is leaning towards a positively skewed curve. So that's all for today's lecture. uh, let us meet again, and I will request you to kindly like and subscribe my channel. Also do comment if you want a specific topic to be covered. I will definitely see to it. Thank you very much.